we have three problems. We project the ball from 5-meter height, goes 20 meters, and hits a wall at a 10-meter height. It didn't say it was a vertical wall, but most walls are, so we can kind of implicitly assume that. As I said, it's not a good idea to draw a line from here to here. Even a dotted line would be misleading, a solid line even more misleading, because then you might start thinking the initial angle is the angle of this line. Okay? And if the initial angle is the angle of this line, you're not going to hit this point. Even if it's a bullet, the bullet's going to drop between there and there. I don't care if it's a high-speed bullet. I don't care if it's a laser beam, it's going to drop. Now, you're not going to be able to measure how far a laser beam drops. Might even be hard to measure how far a high-speed bullet drops, but it drops. Okay? Meaning, you got to start at an angle above this line, right? So now we can say, okay, well, okay, we're going to have a V naught. We don't know what the magnitude of V naught is. We don't know how fast this is going. And we also don't know just what this angle is going to be. So V naught and theta are both unknown. The other thing is, where's our coordinate system? And so, now let's what's x naught and what's y naught, because if you know what x naught and y naught are, you know what your coordinate system is. If you want x naught to be 100 meters down the range there, then x naught would be negative 100 meters. Okay? If you want y naught to be the center of the earth, then x naught is approximately 6.4 times 10 to the 6th meters. Okay? But we're not going to do that because that's not precise enough anyway. We're going to pick the most reasonable coordinate system. The logical places to put the origin would be maybe here, or maybe down here, or maybe up here, maybe down here. It would work no matter where, even if it's 100 meters along the x direction and 3 miles up. Okay? It'll still work because this is going to give you different numbers on x naught and y naught. The x value is going to be 20 meters more than x naught. And the y value is going to be the y of t is going to be 5 meters more than x naught, than y naught, right? And end up 5 meters higher. Not going to be difficult to deal with those numbers. Again, don't go to the center of the earth, there's too much uncertainty. I'm not sure how far it is from here to the center of the earth, and I don't know anybody is very sure. With GPS, we can probably get it down to within a meter. Maybe. But we're not going to get it precise enough to do this problem. Okay. So anyhow, so where am I going to put the origin? Well, there are two pretty natural places to put it. You probably wouldn't put it out here. You'd probably put it over here. It has something to do with your initial position. If you put it down here, then x naught would be 0 because the x coordinate of this point is the same as the x coordinate of this point. If the origin's here, the x coordinate of the origin is 0, so the x coordinate here would be 0. Okay? But if you put it here, the y coordinate would be 5 meters. Not difficult to deal with. If you want to do that, that's fine. Kind of natural in some ways. If you think in terms of orienting everything according to the level surface down here. Okay? To the floor, let's say, or to the level ground. Okay. But if you put it here, both x naught and y naught are 0 because, of course, x naught is your initial position, y naught is your initial position in the x and y directions. So we put our coordinate system here. So here's x, here's y. And the origin is our initial point. So now X naught and Y naught are both zero, so we don't have to mess with them. We don't just skip them. We do all this. We work through all this reasoning so we don't leave something out. So it's a quick acknowledgement. I mean, really all you have to say is, well, I'm going to put the origin here. That makes X naught and Y naught zero. Just write down what I wrote down. That's sufficient. It shows me you thought it through. Shows you that you thought it through, which is even more important. Then AX, well, for any projectile, any ideal projectile AX is 0, AY is negative G. Now, we've been over that many times. That's automatic. But you have to know why. If I ask you to explain, why is AX equal to 0? Because we're neglecting air resistance. Okay? It really isn't. And if this thing's moving fast, and if it's big, then that air resistance could become, if big and light, that air resistance becomes important. But we're ignoring it for now. So we're thinking in terms of cannonballs, not Nerf balls. And the vertical acceleration is negative G. And we don't really know for sure what negative G is right here. It varies from one point of the Earth to the other depending on the density of whatever's beneath us. Okay? If there's a big gold cube right beneath us, a kilometer in on each edge, that's going to have an effect on the acceleration of gravity. Now, if there is a big gold cube down there, somebody will have noted that there's something going on with the acceleration of gravity. You'll start looking for gold and totally kill the world value of gold. That's a lot of gold. Okay. But the point is, there are variations. And we don't know how far we are from the center of the Earth. That has a lot to do with it, as you'll see. The further you are from the center of the Earth, the less gravity is. If you're on top of a mountain, you weigh less than you do here. And there are mountains close by. Climb a mountain, see how light you feel. No, it's not going to be a big difference. The ratio of how far you are at the top of the mountain from how far you are from the center of the Earth to the top of the mountain, or center of the Earth to sea level, is just a little tiny percent of that distance. It's not going to have a big, but it is a measurable difference. Okay. Anyhow, you always have this. You have to understand that. And if you're doing a complete solution of a problem, you have to acknowledge that. You have to explain this and this. And it's G. You might as well use 9.8 meters per second squared, which is 9.81. We're at elevation. That 0.1 might not even be valid here, although I kind of think it is. I think if you go to the top of Mount Rogers, just a few miles away, about 30 miles away, it might be less. Okay? That 1 might not even apply. So we don't mess with that. Now, my lab does. They're big on precision. Don't argue with that. Use the precision with them, and this class, 9.8 meters per second squared is always good enough until we get to Newton's law of universal gravitation and look at some of these differences. And even for quick calculations, especially in class, 10 meters per second squared is fine. You can always reduce that by 2%. Okay, well, anyhow, there we have it. There's any ideal projectile, we have this. Now, that means immediately that this AX is going to be 0. So that this term goes away. AY is going to be negative G. X naught is going to be 0, Y naught is going to be 0, if we put the coordinate system there. So you get X of t equals, well, V naught X times t. I'll leave that blank for a second. That's it. And then y of t is v naught y times t minus 1/2 gt squared. And there are your equations, except we've got to do v naught x and v naught y, right? And I didn't leave myself room because I have no foresight, so I'm going to have to give myself a little more room to write these. Okay, so x of t is going to be what times t? Y of t equals what times t? It should be obvious if you understand vectors that here you're going to get v naught cosine theta times t, and here it's going to be v naught sine theta times t. Didn't leave myself enough room again. Now, you've got two equations. How many unknowns? V naught is unknown, and theta is unknown. Okay? V naught and theta are unknown, as we said up here. Everything else is known. So here we have V naught, and here we have theta. Here we have V naught, here we have theta. Everything else is known. Well, actually it isn't, because we don't know t, do we? Uh-oh. Maybe we got a problem here. Maybe we don't have enough information. Okay? So maybe we need more information. Maybe we need the angle or V naught or t. Okay, I'll leave that as a question. So at this point, we have too many unknowns. Maybe there isn't enough information to solve the problem. And actually, if you think about it, there are a lot of ways we can get from here to here. If we go with a higher angle, we can go up and down as long as we don't go too fast or too slow, right? Okay? So we can adjust the angle for any angle that's above this straight line everybody wanted to draw. There's a solution. So indeed, we need more information. I'm probably not going to tell you how long it takes to get from here to here, but I could. Or I can tell you how fast. Okay, we want to go at 40 meters per second. Now we can figure out how long it's going to take to get there and what the angle is. If E naught is 40 meters per second, that leaves us only two unknowns, theta and t. Okay. Now down here, we know the angle, we don't know the initial speed, and we know, of course, this thing's going to have, be an arc, something like this. Okay. At a given angle, there's only one speed that gets it there. Okay. I tell you, you got to toss this thing up at 53 degrees and have it land, basketball, have it land 1.3 meters higher in the basket, okay? There's only one way you can do that. Now, there are many ways you can get it in the basket. You can have a flat shot, which has to go a little faster, okay? But maybe not. If it's too flat, it has to go pretty fast. Or a high arc, you get somebody 18 feet tall, you gotta get a big high arc, right? Fortunately, nobody's 18 feet tall, so you don't have to shoot over that. I think that'd be kind of physically impossible if they were any good at defense. So anyhow, you get the idea. If you're taking that shot, you have a choice of angles and velocities, but one determines the other. Okay? So just an intuitive connection. Well, it's the same equations. In other words, this equation and this equation. So let me just kind of circle these equations in yellow. There are the equations. So in this case, what do you know? You know that, first of all, it's probably a good idea to go ahead and put the origin of coordinates here. Coordinate system here means that x naught and y naught are both 0. So you have x of t equals what? Well, it's v naught x times t, right? What's v naught x? V naught cosine theta times t. And that's it. Because, again, your acceleration is 0, right? Y of t equals v naught sine theta times t minus 1/2 gt squared. Okay? Now there's one more thing you know. What else do you know about these equations? Well, x of t is 70 meters, right? Also, y of t is negative 10 meters, and that's going to be problematic. So now we can say $70 meters equals v naught times a cosine of 53 degrees times t, right? Well, immediately you can solve this for t in terms of v naught. Okay. So you could solve for t. And then you plug that t into the second equation, and the second equation is going to become I said y of t is 10 meters, and of course it's negative 10 meters. I'm not sure I even said the negative, but clearly it's 10 meters in the negative y direction. Then negative 10 meters is v naught sine of 53 degrees times t minus 1/2 gt squared. And again, we have unknowns. V naught and t, which occurs in two places. Well, if we solve this equation for t and then plug that in here, then everything's in terms of v naught, right? and the V naught's gonna be in the denominator. Which means that this T is gonna have a V naught in the denominator that'll divide out the V naught you have here. This will have a squared V naught in the denominator. That's gonna be okay. Because V naught's gonna be the only thing that's unknown. You're gonna be able to solve for V naught. That's gonna be an easy equation to solve. So that's an easy situation. And again, we know intuitively that if we give this just the right speed, it's gonna land there. It is possible to land here with a 53-degree initial angle. Over here, well, we go through the whole process, and I'm going to abbreviate it a little bit for time because I want to get to the third problem. So this problem is identical to this one, okay? As long as a straight line from here to here is down below a 30-degree angle, okay? If you did the straight line from here to here and that line was at less than 30 degrees, there's no speed that would get you from here to there, okay? Because even a straight shot at infinite speed would land before you get here. Now you want to think that through. But you get an x of t, again, with the origin where it's convenient. So x naught and y naught are both 0. Now V naught x is going to be V naught times the cosine of negative 30 degrees, since this 30 degrees is in the negative direction. Well, cosine of negative 30 degrees is the same as cosine of 30 degrees because cosine is an even function. It's going to be important in y of t. And now, what do we know? Everything but V naught and t. So it's exactly the same problem. The only catch is, if I make this point too far out, we can't get there because a straight path would lie at an angle closer to horizontal than 30 degrees. And since the thing is going to land closer to here because it's falling down the straight line, you would get a solution. And that means you would end up, you solve this equation for t in terms of V naught, plug it in, but you're going to end up with a quadratic equation that has a negative discriminant, so there's no solution. That's it. Okay, well, we want to go on and talk about the third problem, at least.